Welcome to video 7, the summer homework packet answer key for problems 17, 18, and 19. Alright, 17a. This problem here is actually very tied to calculus. In fact, when we start in our calculus, this is some of the very first stuff we'll be doing. You don't need any calculus per se to do it. This is all algebra skills, but it sets up the formal definition for the derivative, which is a big piece of calculus. So understanding this problem would be of great benefit to you because we will be doing this several times in class. What it's asking us to do is find f of x plus h minus f of x over h for some given functions. And this is a piece of the definition of the derivative, and we will eventually learn shortcuts for the derivative, but for now we need to know where it's derived from. So if our function is in part A 2x plus 3, what that means is the first time we do f of x plus h, and then from that we're going to subtract f of x and divide that all by h. And then they want us to simplify this down. So let's distribute and do what we can to simplify it. 2x plus 2h plus 3 minus 2x, and then we distribute that negative minus 3 all over h, and start canceling what we can. 2x cancels with negative 2x, positive 3 cancels with negative 3, and we're left with 2h over h, and naturally the h's cancel and we get the answer 2. So as a tip, the linear equations will reduce to whatever the slope is. So that's a tip for you. If you didn't get there, then you made a mistake. Other equations will be a little bit more complex than that, but the linear equations, that's a really easy check. Alright, 17b wants us to do the same thing to the equation 1 over x plus 1. So what we get is f of x plus h will be x plus h plus 1, and then f of x will be x plus 1, and then this is all divided by h. And we need to simplify this. And this one, we are simplifying our fractions first, the fractions in the numerator. So our left-hand equation, needs to be multiplied by x plus 1, our left-hand fraction. And our right-hand fraction needs to be multiplied by x plus h plus 1 to give us a common denominator. Now that we have a common denominator for our two fractions in the numerator, we can combine them into a single fraction. So that single fraction has the denominator x plus h plus 1 times x plus 1, and the numerator, the x minus x cancels, the 1 minus 1 cancels, and we're left with just a h on top, and there's the negative in front of it, so we need to subtract it. So there's our numerator simplified, and that's all divided by h. And the same thing, dividing by h would be the same as multiplying by the reciprocal of h, and so we can do that, and the h's cancel, and we're left with negative 1 over x plus h plus 1 times x plus 1. And as you can see, this one didn't simplify down nearly as easily as the linear equation. And we'll learn a trick, again, to do this shorter, but for now we need to understand the algebra behind it. Okay, in 17c we're doing this to the equation x squared. So first off we have x plus h squared, minus f of x divided by h. If we simplify our numerator, let's expand. The x plus h squared becomes x squared plus 2xh plus h squared. And then we subtract x squared, and that is all over h. Our x squared cancels with our x squared, and we're left with 2xh plus h squared over h. And we're able to factor in h out of the top and bottom. So once we do that, we have 2x plus h over h, and the h's cancel, and we're left with 2x plus h as our final answer. So again, we're going to learn shortcuts to these problems, but for now we need to understand the basic difference quotient right here. So this is sometimes referred to as a difference quotient, which is a piece of the definition of the derivative. Okay, let's move on to problem number 18, which is about sketching graphs of functions. Okay, we are asked to sketch the graph g of x equals the absolute value of 3x plus 2. And the first thing I want to do is change this into transformed standard transformation form. So what I can do is, if I factor a 3 out, I get x plus 2/3. And what that does is it kind of isolates the x plus a number term and the stretch factor here. So the first thing is we know that the graph has shifted left 2/3 of a unit, because the x has been replaced with x plus 2/3, and then we know that the graph has a vertical stretch by a factor of 3. And our basic function, there should be a straight line here, our basic function is an absolute value function, which we know looks like that. So when we go to sketch this, what we want to do is move to the left 2/3 of a unit. So there's the vertex of the absolute value, and then the vertical stretch is going to be 3. So we're going to go out 1, up 3. Out 1, up 3. So we've vertically stretched it by a factor of 3. There we go. To the left 2/3 and vertically stretched by 3. Okay, when it comes to sketching 18b, this isn't so much a transformation on a parent function. It's a little bit harder to think of it that way. But if we understand what's going on, it actually isn't that difficult to graph. Let's first think about what's inside the absolute value. This is a parabola. This is a second degree function, if you want to think of it x squared minus x, like that. That's a parabola, and we know parabolas open upward. And because it's in factored form, we can see that there's a 0 at 0 and a 0 at 1. So technically we've got a parabola that looks something a little more like that on the inside. And we are going to take the absolute value of it, which means the part that's negative will get flipped and become positive. So we have a graph which looks a little more like that, because this negative part here was flipped. And that's decent enough for a sketch. If we wanted to get into more detail to figure out, the height of this, we could do that, but I think at this stage of the game it's more important that we just understand the general look of the curve. With calculus skills we get far more advanced, and we can figure out, all these things. Where is it concave up or concave down? Where is it increasing and where is it decreasing, etc. The maximums, minimums. Okay, moving on to problem number 19. We're given the graph of a function and we're supposed to sketch the graph of transformations to that function. So it's more sketching. Okay, 19a, we're asked to sketch f of x plus 1. And we know that what that means is a shift to the left 1 unit. So all of our key points move left 1 unit. So we get the straight line right there, and then it kind of does the curve and dips down like that. So let's erase this piece right here. But that's a shift left 1 unit. Pretty easy. Okay. For 19b, we're asked to graph f of negative x. And when we switch x with negative x, what that does is that flips it horizontally. So all of my positive x's become negative x's, and all of my negative x's become positive x's. So you can think of it as drawing a mirror along the x-axis. So our new graph winds up going up, and then it has that kind of curve that comes down like that. So a mirror image on that axis. All right, for 19c, we're asked to graph the absolute value of f of x. And so what that means is you can take your graph, and any time that you have a negative value, you're going to mirror it or make it the absolute value of that negative value. So our graph winds up taking this negative portion here and mirroring it up here, thus resulting in all positive answers. Because when you take the absolute value of something, you get a positive value. Okay, finally for 19d, what I have is the function f of the absolute value of x. And this is the one that requires probably the most thinking out of the 4 of them. Let's think about this. If I asked you what is f of negative 2, you would go to negative 2 and you'd say, f of negative 2 is negative 1. But if I then plug it into the blue function here, f of negative 2 would actually be f of 2. So rather than going here, I get this value, and it would return an answer of 0. So f of negative 2 plots at 0 when I'm taking the absolute value of it. Similarly, if I ask, well, what does f of negative 1 return? Well, I plug negative 1 in here, and what I'm really asking is, what is the absolute value of negative 1? So what is f of 1? And f of 1 returns a value of 1. So we plug that in. And what you see happens is we wind up creating a mirror image of the right-hand side of the graph. So the absolute value on the x will mirror the right-hand side of the graph. When we did the absolute value on the outside, it mirrored the negatives to the positive, the negative y values to the positive y values. When we do the absolute value on the inside of the function, just to the x, it mirrors the positive x values get mirrored over into the negative x values. This transformation, I think, is the trickiest to understand or to memorize, but once you get it down, it's actually a pretty easy one to do. So there we go. That's the video for the day. Stay tuned for more videos coming up.